Hey, welcome to another Dev Diary. Talking about crowd collision today. So I'm dusting off the old top-down 2D ARPG thing. We got the inventory system with the fan out. We got blocks that block collision. You can open and shut doors. There's a little vision system that I'm working on. There's skeletons that chase your little character. Uh, you can shoot fireballs at them. And they have health bars that go down as they take damage. The problem I was running into is that they clump up too much. So after I give them an attack, they don't have an attack yet, but when they can attack me, when they're clumped up this much, if you get close to them, they'll all attack simultaneously, and they'll kill you in one hit. So they need to spread out some, and if they're all clumped up too tightly, then you can take them all out with a small AOE ability. So we need them to spread out. So I tried a whole bunch of different solutions, and I want to show you all those different the sort of the progression of my ideas over the course of this development process. So the first thing I tried was the brute force solution, just to have uh, all the characters do checks against all the other characters every single frame, and that just fell apart. It was not, if the number of checks you're doing is the number of characters times the number of characters, checking each character against every other character, then that's n squared. So in other words, the performance gets exponentially worse as you add more characters. So we got to avoid that. So the first solution to try to fix the performance issue here was to add these little things that I was calling springs. So what a spring is it's an object that doesn't really live in the world, but it's updated independently, and it has references to two different characters. And when it's updated, it checks to see how close those two characters are, to see if they're colliding. And if they are colliding, it pushes them away from each other a little bit. So what this does is it makes it so that you don't have to search for which characters are colliding with each other each update. It's already kind of baked into the object model, but it also shares that collision check between the two characters, so that it only has to do it once. It does one check for each character. Now I knew this would still be bad performance because it's n squared divided by 2 essentially, because you're only doing half as many checks, but it's still that still gets exponentially worse as you add more characters. But I had been going around in circles thinking of ideas, so I figured I'd just go ahead and implement it. Um, it was fine when there wasn't that many characters on the screen, but when you add more, when you get to like 200 characters or so, it was just overwhelming, the performance. Um, so I really liked the way that it behaved with these little springs. Like your character could kind of shove its way through a crowd. The skeletons kind of jittered a little bit, but it wasn't too bad. And in general, I liked the way they behaved. So I wanted to try to find something that behaved like this, but with better performance. But since the performance gain from the springs was negligible, I decided to just move on to another idea. So the next idea I tried was to have cells that have references to the characters. So you'd essentially be each cell would have an owner, and when a character owns that cell, other characters can't come into that cell. Now this gave me sort of like flashbacks of StarCraft Brood War and how terrible the pathing was there. Like you had one character, they couldn't push through a crowd of characters the way they could in StarCraft 2. But I figured I'd go ahead and try it. Um, so the end result was that it was very mechanical looking once I got it working right. Uh, it was sort of, I don't know, inorganic. It was interesting looking, sort of mesmerizing, but it didn't really have that same feel of the behavior that I had back when I was using the springs. You couldn't push through this crowd either. So the next thing I tried was making it so you could shove characters out of their cell when they're the owner of the cell. Now, this allowed you to finally be able to push through the crowd while having good performance. It just looks really weird though, because it's each character is only interacting with the owner of the cell. So if there's one owner of the cell and three other characters in there, those three other like invading characters don't collide with each other in the system. They only interact with that one character, and they're all pushing that one owner of the cell out. And so this gives it sort of this popcorn effect, where you always see these big characters being shoved in a big way out of their cell constantly in all the different cells, and it just looks like popcorn. So the next idea I tried, and this was a big aha moment for me. So what I did was make it so that, like, the big issue with the springs, like I had the idea that the springs could break if you moved away from each other, and that would be really easy to do. They're already checking the distance between the two objects, so if the distance gets over a certain threshold, the spring could break. The problem is knowing when to form the springs. So in that first example I showed you, they just created the springs as soon as the character was added to the game. But if there was a way to create the springs on the fly, that would mean I could have the threshold for when they break be really short. But I couldn't figure out a way to create the springs without having the same really poor performance of the brute force solution. And it would be okay if that was a one-time cost, but I don't know how often you need to check to see when more springs need to be generated. So the big aha breakthrough moment was, instead, when we have the cell owner and the invaders of that cell, when one of them invades the cell, instead of trying to push away immediately, you could just have that as the trigger to form the spring. And so that ended up working really well, because I could only form this. It gave me a way to know when to create the springs and to be able to do it in a very efficient manner without having to check every character against every other character. So now that we're creating the springs in a very efficient manner and having the springs break in a very efficient manner, and I made the spring, the break distance on the springs be very short. So you have to be almost touching each other for the spring to stay there. Like my goal was to have it as short as possible without it thrashing back and forth of creating the spring and breaking it over and over again. So I kind of tweaked it until it was at that sweet spot where the spring wouldn't break unless the characters actually moved apart from one another. So what this did is there's far fewer springs in the system, because you only have springs between characters that are almost touching each other. And we're creating them quickly, we're removing them quickly, and we're still doing, only one check for every two characters. So they're sharing the collision logic between them. And this finally was really good performance, but it also had that organic feel of the original brute force solution. The character could push through a crowd, and it's working really well. I'm very pleased with how good the performance is and how good the behavior is. So I'm checking to see if the spring already exists between two characters using a hash table in C#. It's a dictionary, and a special hash function. So I started from the tuple implementation I found on Stack Overflow, but I wanted to make sure that character A connected to character B yielded the same hash code as B connected to A, so the order shouldn't matter. So I modified it a little bit, and it seems to work well. And this is an efficient way to start from the characters and then map that to the spring that connects them. So the skeleton, I haven't experimented yet with vector field path planning. So vector field path planning is something that's used in RTSs a lot. It essentially puts vectors in each cell to tell the units where to go rather than having an individual path. And that vector field is shared among all those units that were given the command at the same time to move, as a way to not have to plan paths for each character each time. And it also makes it so you don't have to really, it doesn't matter what cell you happen to be in that field, you always know where to go next to arrive at the destination. I have not done that yet though. So this path planning that I have currently, each skeleton is planning its own path to your character, which is really encouraging because it shows how efficient the path planning I did previously is still working. Now I have some ideas on how to make it even better. I might do that in a future video, but if you want to see details on how my path planning works, there's an older video on my channel you can check out. The high level view of it is that yes, it's A star, but it's not doing A star through each individual cell. There's pathing regions, and there's these things called anchor points that live at convex corners, and it plans a path through that instead, and it makes it super efficient pathing because there's not very many nodes that it has to discover the path through. So it's really cool that all these skeletons can like plan their own paths, and they're bumping into each other as they go. And I just thought that was very awesome that I was able to get that much performance. It was very encouraging. I still don't think it's enough to be able to do the very simulation heavy stuff that I want to do, but I've already kind of got it in my mind that ARPG and simulation heavy would probably be two different games. I don't know. I've always wanted to do something very, very simulation heavy though. Like have a world that really feels real and changes even when you're not looking at it and that kind of thing. But that's for another day. I guess I wanted to do here at the end of the video, do a really quick channel update. It's been a few years since I put out a video. I have still been working on this a lot in the background. I've been working on other projects too. I've been doing a lot of planning and design work because I've run into, in the past I've had the idea that, just hindsight's 20/20, so go ahead and dive in so you have a better idea of what you're doing. But the game dev stuff is so much more complicated than anything else I've ever done coding wise that I've sort of taken a habit of going back and trying to plan stuff out more. So I've filled a whole bunch of graph paper notebooks up with ideas, and I've been working on a whole bunch of different little projects here and there. And what you can expect from this channel in the future, I don't know. I might not put out another video for another couple years. There certainly won't be frequent videos, but I'll also probably each time I put one out, it'll probably be on a different topic, maybe even a different project. So don't expect me to stay focused because I'm not going to do that. I'm just going to follow my muse and pursue whatever's interesting to me at the time. But anyway, thanks for watching.